Okay, so continue with chapter 8. This is it's what I would call a spreadsheet example of calculating the standard deviation for Martin products. So they down here we have the returns. This is 110% and a boom, 22% and a normal, and then a loss of 60% in a recession. Our mean of our expected return of 50 minus that, so is of 15%. So this is our deviation. So this is deviation from the mean. We square that, and then we multiply it by the probability. So then once we do that, once we multiply it by probability, we get these totals. We add those up, and that gives us the variance. We take the 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 square root of the variance, and that gives us standard deviation of 59.3%. So I'm going to try and write this out the way it the formula should look. So sigma squared. So say sigma squared m for Martin products. So we had let's do this way. I always put the probabilities first. So zero point 0.2 times the expected return in a boom economy minus the mean of 15%. We square that plus 0.5. This is a reset. This is a normal economy. Then a 22% return minus the mean. Square that plus 0.3 multiplied by the expected return of loss of 60% minus the mean. Square that, and that should total to 3,517. Okay, we take the square root of that, and then that gives us standard deviation for Martin products of 59.3%. So this tells us that we're talking. Most cases, we're talking about a normal distribution. That tells us that like 68.5% of the outcomes ought to fall within plus or minus 59.3%, which obviously is a very huge deviation. So estimated standard deviation, if we don't have like the likelihood of outcomes, we'll use historical figures to calculate standard deviation. So what we want quite a large sample size, maybe 100 observations or something of that nature. In a lot of cases, when we talk about returns, we'll when we're doing this type of analysis, we would use like monthly or even daily returns on a stock to do these types of calculations. So we take the sum of our squared deviations, and then we divide it by n minus 1. This is supposed to make the estimation of standard deviation more robust, make it more. We're reducing the size of the denominator, which makes our standard deviation large. So the way we calculate our mean is we take all those historical observations, that's these R1, 2, and with the funny dots over the top of them, we sum them up and we divide by the number of observations, and that gives us the mean of our sample. Coefficient of variation. The coefficient of variation is the standard deviation divided by the expected return. It's useful for evaluating investments where the risk and expected returns are different. If we're comparing returns, if two investments have the same expected return and one has a lower standard deviation, that investment would dominate or be preferable to the other. But in a lot of cases, we'll have different expected returns and different standard deviations. This coefficient of variation allows us to adjust for that. The coefficient of variation, or CV, is the risk divided by the return. So we take the standard deviation and divide that by the expected return on that stock. Risk aversion and required returns. So risk-averse investors will require higher rates of return to invest in higher risk securities. So in a lot of cases, there are investors who may not invest in higher risk securities at all. The pool is going to be smaller, so that's going to even increase the required rate of return even more. Risk premium is a portion of the expected return that can be attributed to the investment's riskiness. So the difference between the expected rate of return on a given risky asset and that on a less risky asset, with homework problems where we calculate the expected returns for two different assets and compare them. This chart graphs the risk-return relationship. So on the y-axis we have return, and on the x-axis we have risk. So when we have below average risk, and above average risk. So as risk goes up, the return required is going to go up. So because investors are risk averse.